Okay, welcome back. Let's continue this approximation. We have examples. For example, we have those numbers. First number A is 3.14159. If we say we round it to 2 decimal places, if we round it to 2 decimal places, you check that you only keep 3.14 because you round it. You check the next digit is 1. It's less than 5, so you drop it. So if you round it to 2 decimal places, it's 3.14. If you round it to 4 decimal places, okay, 1, 2, 3, 4. Only decimal. 3 does not count. So you have 5. 5, you check next digit. Next is 9. 9, it's bigger than 5. You have to add 1. So it's a 3.1416. 5 plus 1, 6. Okay, so that's a round. And truncate it to 2 decimal places. Truncate it to 2 decimal places. You don't care what's next digits, just cut it at 2 decimal places. And truncate it to 4 decimal places. To 4 decimal places, again, you just consider up to 4 decimal places. 9, even it's very big, it doesn't care. It doesn't matter. So it's a 3.1415. That's the difference between the truncation and the rounding method for the approximation. Okay. Okay. So next we will study the operation of numbers. We will review the operation of numbers. We know that we have addition, subtraction, multiplication, division, and they have certain properties. So I'm going to list all those simple or important properties. So we have addition, subtraction, and multiplication. So here, operations. That's operation. We have plus, minus, times, divided by. And we know that for the addition, it does not depend on the order. A plus B is is equal B plus A, and the product has the same order, same property. A times B is B times A, and this is a so-called commutative property. And all these things are on page 10. Check page 10. So A plus B is B plus A, and A times B is B times A. And then we also have a so-called associative property. Associative properties means if you have several addition, you can do whatever order, A plus B first or B plus C first. It doesn't matter. This is called associative. And you will see that addition and multiplication, they share some similar properties. The multiplication also has this associative properties. Okay? And then you have interaction between the addition and the multiplication. That's the distribution properties. Distributive properties. Distributive properties means if you have A times B plus C, you have brace, then it is equal AB times AC, and you can put it first or second. It's a AB times AC, the same thing, because the order does not matter for the multiplication. Okay? And for the addition, there's a special number, 0. 0 plus whatever number is A. It doesn't matter at which place. And this is identity. We call it identity property. And similarly, for the multiplication, we have 1. 1 times A is A times 1. Okay? So that's our identity. And the other one is called the additive inverse. Additive inverse. Additive inverse property means for whatever number, it always has its counterpart negative of it, so that the sum of them is 0, the negative of it. So for any number, you can always just put a negative sign, get its additive inverse. And we said that multiplication is very similar to the, for the property, it shares most same property for the addition. So there is the multiplicative inverse property, but there's a slightly small difference. For any number, you can always flip it so that the product is equal to 1, right? 2 times 1/2, 3 times 1/3, 3/2 times 2/3. You just flip it, you will get the multiplicative inverse. But there is an exception. A cannot be 0. 0 does not have multiplicative inverse. It's a difference. And 1/A here is called the reciprocal. Is called the reciprocal of A. Reciprocal of A. Okay. And there are rules of signs about quotient, like for example, A/B is A times 1/B, and A times 0 is always 0 for whatever numbers, and 0/A is always 0, and A/A is always equal to 1, but here A is not equal to 0. And if you have a negative sign, negative A times B is A times negative B is negative A times B. And if you have two negative signs, negative A times negative B is equal to A times B, because two negative signs are cancelled. And you have a negative of a negative. It's like a mirror. You have twice of image. You get itself back. And for the, it is a product, you also have the quotient version. You can put this negative sign at whatever place. For the product of two negative symbols, you can cancel them. For the quotient of two negative symbols, you can also cancel them, right? So those are the basic property. You already know that. And after that, we have cancellation properties. If AC is equal to BC and C is not equal to 0, because if C is equal to 0, naturally A times 0 is 0, B times 0 is 0. It's always correct. Then you don't have any conclusion. If C is not 0, then A must be equal to B. Okay, so you more or less like cancel this C from the equation. You get A equal to B, but you can only cancel a non-zero number. And A times C over B times C, of course here it has to make sense, so the denominator is not zero. If this one appears, you can cancel C, it equals to it is equal to A over B. But here we need B is not equal to 0 and C is not equal to 0. The denominator cannot be 0. Okay, so this is a cancellation. Cancellation. And if you have a product, two numbers equal to 0, 2 times 1 is 2, 2 times 6 is 12. If you have two non-zero numbers, their product is never to 0, it's never equal to 0. But if you have a zero product, then either A is 0 or B is 0. You can conclude that, or both, of course, or both. You can conclude that at least one of those two numbers must be 0. Okay? Okay. And the other one will be the addition of two rational numbers. So how do you add two rational numbers if they do not share the same denominator? If they have different denominator, you're going to first multiply the first rational numbers by D, by the denominator of the second rational number. And the second rational number you multiply by the denominator of first rational number. Now they share the same denominator, so if they have the same denominator, you only add the numerator. That's addition. And the product is simpler than addition. It's just numerator times numerator, denominator times denominator. Okay, this is the product. Quotient, if you have A over B, this is a rational number, over C over D, a second rational number. A rational number over rational number is equal to A over B times the reciprocal of the denominator. Okay, reciprocal of the denominator. Okay, so that's the basic operations. So we just listed them and make sure you understand. And the other one is called the least common multiple. The least common multiple, for example, when we talk about 15 and 12, multiple, what is a multiple? The multiple of 15, you have 15 times 2, 30, times 3, 45. They are all multiples of 15. You can continue this. It does not have end. Just multiply 15 by some large integer, then you have multiple. And for 12, you can also do the similar operation. You will have certain multiples. And some moment you see that their multiple, the common multiple appears. The first appeared common multiple, because if you continue this, this common multiple is not unique. You will have a lot of common multiple. You see here, this is also common multiple. But the smallest common multiple is called the least common multiple. We use LCM. the least common multiple is useful or helpful, at least it is helpful when you try to add two fractions, two rational numbers. For example, if we want to add 8 over 15 plus 5 over 12, assume you know that the least common multiple is 60. And 60 is 15 times 4. You see here, times 1, times 2, times 3, times 4. So you are going to multiply top and bottom by 4 for the first rational number. For the second one, 60 is 12 times 5. So you multiply top and bottom by 5. 5 times 5, 25. 6 times 5, 60. Okay, now you see that you already have 60 as a common denominator. You don't have to 15 times 12. 15 times 12, you see here, 15 times 12, 30, 180. It's too big. To use LCM, the least common multiple, we just want a small denominator. Small denominator means you will save time, you will avoid mistake. You may avoid mistake. Okay, so when you have least common multiple, you have 60, you add the numerator, so it's 57. Okay, and that is the usage of the least common multiple. Okay, so that's everything discussed in the first section of the review chapter, R.1, the real numbers. All those concepts should be familiar to you. If you at certain places confused or don't understand, send me email and try to do the exercise as many as you can. Make sure you understand them. Okay? So that's the first section. Remember, our class, every day we have 2.5 hours. So I will continue. R2. The second section is called the Algebra Essentials. Algebra Essentials. Algebra Essentials, let's see what the section covers. So we already know what real numbers is. Real numbers, rational, irrational. Rational numbers, ratio of two integers. Integers, positive and negative, 0. Okay? So in order to visualize it, we draw a line. We call it a real number line, the real number line. And we label the point, the numbers on this real number line. So for the real number line, you need 0. The place of 0 is called the origin. And you have to know where is 1, where is -1, where is 2, where is -2. And of course, it's up to your problem. If your problem is like, okay, we talk about like a number less than 10. So if your problem is very small, you can put 10 here and you divide divide the interval equally into n pieces. But whatever, when you get this 1, it means this segment will represent a length 1. And this is called the scale. So when you put 1 here, then you have to draw similar places in the opposite side as -1. And this is 2. And this is a 3. And so this when you determine 1, you have the scale. Of course, I can draw this way. 0. I put 1 here, so the scale is this place. This is a scale. It's up to your problem. If I draw this way, possibly I will only discuss the numbers between 0 and 1, because if I want to discuss 10, I have to shrink it. It's too big for my paper. Okay? Okay, so let's see the definition, some definition. The coordinate. The real number associated with a point P is called the coordinate of P. Okay, so for example, if I put P here, okay, this is a point P, and the corresponding number is 3, so we say the coordinate of P is 3. Okay, so the line whose points have been assigned coordinates is called the real number line. Okay, so the real number line means every point has a coordinate. Every point has a coordinate, the real number line. And normally we put positive numbers on the right side and negative numbers on the left side. That's a convention. We don't flip it. Okay, and the 0 is always the origin. Okay, and we also know that the product to positive is positive, the product to negative is also positive, and the product to a positive and negative is negative. Okay. Okay, so in this on this number line, we can label something. For example, if we have a number line, remember we already say that our right side is positive, left side is negative, and from this number design of the number line, we see that it's 0, 1, 2, 3, 4. If you go to the right, the number increases. So when you have A and B in this relative position, we know that A is less than B. Okay, if we have this relative position, we mean A is equal to B. And of course, if we draw it in the opposite way, is A is greater than B. So right side, the number on the right side is greater than the number on the left side. Okay. And there is some difference. Sometimes we write this way, or sometimes we write this way. Right this way means A is strictly less than B. A cannot be equal to B. So this is called a strict inequality. And here it means possibly A is equal to B, or A is strictly less than B. This is called a non-strict inequality. Okay, so there's one more chance A equal to B. Here, that's not going to happen. Okay, so for example, if I try to draw x greater than 4, x greater than 4 means you have 0 here. I'm not going to draw 1, we directly draw 4. We'll put this round parenthesis and put to the right. So this is x greater than 4. Okay, this is round. If I want to describe x is less than or equal to 5, again, 0, 5. And this time we're going to use the symbol represent, it include the right bracket. The right bracket to mean we include the possibility x equal to 5 to the left, less than to the left, greater than to the right. Okay, less than to the left, greater than to the right. Okay. And when we have a real number line, we have 0, we have a point. When you have the point, you have the corresponding coordinate. Then this point, origin normally we use big O, not 0. Then the distance between the origin and the point is what? Is so-called the absolute value. The absolute value of a number A is this associated coordinate, is the distance from 0 to A. Technically, it's from the point origin to the point associated to the coordinate A. Okay, so that's the absolute value. And because it's a distance, absolute value is never negative. There's no negative distance. Distance is always 0 or positive. Okay? Okay, and let's check that. If you have 3 here, then the distance is going to be 3. If you have, well, -4 here, then the distance, we check that there's 4 units between them, so the distance is 4. How do we get 4? 4 is the opposite. Remember, they are opposite to each other, the inverse. So when you have 4, its inverse is -4. When you have -4, its inverse is -4. The inverse of -4 is -4. Its inverse, the inverse is always you put a negative sign. Whenever you talk about additive inverse, you just directly put a negative sign. Okay, so this observation gave us the definition. The absolute value is defined by absolute value of A is equal to A. If it's on the right side, you see, just read it. Absolute value of A is equal to, if it's on the left side, it is equal to its additive inverse. Additive inverse, negative A. For whatever number, its additive inverse is negative. Is a negative of that symbol, not a negative number. This is a positive number, but it's a negative of the symbol. Remember that whenever you have A, its additive inverse is negative A. It doesn't matter additive inverse is positive or negative, but it has a negative sign. Okay? Okay. So that's it. And absolute value is always greater than or equal to 0. Here you have negative sign, but A is already negative. The negative of a negative number is positive. The negative of a negative number is positive. The negative of a negative number is positive. Okay? It's like a tongue twister, but yeah, you understand it. And The ops value is the distance between the origin and a point. If you have 2 points, ignore the origin, just 2 points. What is the distance between 2 points? The distance between 2 points is always the ops value of the difference. Is always the absolute value of the difference. It doesn't matter who minus who, because you put ops value, it eliminates the negative sign. Okay, so you check that. For example, if here's a here 3, here's 2. Remember, zeros between them. So here 2 units, here the 3 units, so the total is 5 units. And if you get 3 minus negative 2, check it. 3 minus negative 2 is 3 plus 2. It's 5. Or if you have a negative 2 minus 3, negative 2 minus 3 is negative 2 minus 3 is negative 5. But the ops value of negative 5 is positive 5. Just get the positive counterpart. Okay, so it doesn't matter which order you put, it's always a difference. Okay. Very good. Next, we're talking about algebra. Algebra means we heavily use letters. We will use A, B, C, D. So we use X, Y, Z, A, B, C to represent numbers. They can be, for different problems, they represent different types of numbers, but they are not fixed. X is not fixed. X can represent 1, X can represent 10. So they are called variables. Okay, so you have variables. And except variables, if you do have a number in the expression, it's called a constant. Okay? Or like pi. Pi is a letter. It's a Greek letter. It's a letter. But pi represents some specific fixed number. So a constant is either a number, 3, 5, square root of 2, or represent or a symbol representing a fixed number. Constant could be a symbol, a special symbol, or just a number. When you have variable, we say you have an algebraic expression. Like for example, x plus y, or x plus 1 over x minus 1, algebraic expression. They can represent a lot of values, because x can be 1, y can be 2, or x can be 100 stuffs. And for the algebraic expression, sometimes we care the value with a specific input. So we say that we evaluate if x is 3, y is -1. So For example, if we have 3y over 2 minus 2x, if we try to evaluate the expression if x is 3y is negative 1, it means whenever you see 1, you put a negative 1. Whenever you see x, you put 3. 3y is a 3 times y, so it's a 3 times negative 1. 3 times negative 1 is negative 3. 2x means 2 times x, 2 times 3 is 6. 2 minus 6 is negative 4. Negative 3 over negative 4 is the 3 over 4. This is the evaluation. This is an evaluation. Okay? Evaluation. So whenever you try to evaluate the expression, just plug in the data. And for those algebraic expressions, you see, especially for this case, for this one, we say that whenever you have fraction, the denominator cannot be 0. So for x plus 1 over x minus 1, x minus 1 cannot be 0. In other words, x cannot be equal to 1. It means if x is equal to 1, the denominator becomes 0. This fraction does not make sense. So you cannot evaluate the problem, evaluate this expression at this 1. Okay? So that means, or that's what we say, that is that 1 is not in the domain. The technical definition is the following. The set of values that a variable may assume is called the domain of the variable. So for example, the domain of this is a set of all x such that x is not equal to 1. Okay? So, for example, the domain of x plus 1 over x minus 1 is the set of all x such that x is not equal to 1. When x is equal to 1, you get a 0 denominator. That's a problem. But if you have x plus y, x can be whatever number, y can be whatever number. So the domain will be all x and all y. Okay. Then another part in the section 2, algebra essentials, is the power or exponent, law of exponent. Law exponent. Exponent, remember, a to n is a times a times a, n copies, n factors. It's just a short way to write the repeated product. And of course, we know that a1 is just a. And there are a bunch of important properties and laws. So first, before that laws, we have two definitions. First definition, here this n is an integer, a natural number, sorry. N is a natural number. So you really have like 2a to product, or 3a to product, or 1a to product. So that's a natural number. But we also define a to 0 is equal to 1. We don't do the product for the 0. 0 times whatever number is 0, so it's not equal to 1. So If you have a non-zero number, then you take zero's power. Non-zero number a to 0 is always equal to 1. And if we have a negative exponent, it means we flip it to the denominator. A to negative n is 1 over a to n. Again, a is not equal to 0. Whenever you have product, you don't count 0 because you multiply by 0, it's always 0. It's not interesting. Okay, so that's the definition. First, the definition for the natural numbers. Second, you define for the 0 and for negative natural numbers. So far, we have the definition for all integers. Natural numbers, 0, negative natural numbers. So we have integers. Okay, with those definitions, we have the laws of exponent. The laws of exponent is the following. If you have a to m times a to n. For the algebra, whenever you have two different letters, you don't write any operations. It means it's product. Okay? So when you have multiplication, you have addition. When you have division, it corresponds to subtraction. Okay? And if you have a power, and the power is a to m times n. If you have a b to nth power, is a to n b to n. Of course, if you have a over b to nth power, is a to n over b to n. Okay. Whenever you see the denominator is not equal to 0. So here we have to emphasize it is not equal to 0. Technically, a is not equal to 0. We don't study 0 to whatever power. Okay. So for example, let's see if we example. Let's start from the simple one. If you have x to negative 3, x to 5, is x negative 3 plus 5 is x squared. If you have x negative 3, and then here, be careful, you must put parentheses to emphasize first you take this power function, and second you take this power. Then it is equal to x to negative 3 times 2 is x to negative 6. X to negative 6 is 1 over x to 6 by the definition of the negative exponent. Or if you have like 2 over 3 to 4th power, by the definition it's a 2 to 4 over 3 to 4. 2 to 4 you compute it, it's a 16. 3 to 4 you compute it, it's 81. 3 times 3 times 3 times 3, 4 times, right? Okay, so that's a simple operations. And if we want to simplify it, let's check. For example, if we have x to 5, y to negative 2, x cubed, y. Be careful, all these stuffs can only be done if they share the same base. If they have different base, you cannot combine them. And for this one, you can only handle x with x and y with y. So x to 5 over x to 3, remember here, this one, it is equal to x to 5 minus 3. Y to negative 2 over y means y to 1, so it's negative 2 minus 1. It's always subtraction. It's always subtraction minus the exponent from the denominator. So it's x squared y to negative 4. So we can write x squared over y to 4. Y to negative 4 means it's in the denominator, right? So that's a stuff. the next part is about the square root. Square root. Square root of 2, square root of 5, square root of 7. It's the opposite operation of a square, right? So you have 6 squared 36. Negative 6 squared is 36. So 6, negative 6 are both square root of 36. 1, you can find it. This symbol is called the radical symbol, radical sign. I'm sorry, no 2. Just this symbol is called the radical sign, whatever, we just call it square root. And if you don't put negative sign, it's always positive. It is used to denote the principal or non-negative square root. So for example, this, if you don't put any symbol, a square root of 36 is 6. It represents 6. How do we get a negative 6? Put this way. The negative of square root of 36 is negative 6. Okay? And from here, you see here, 6 squared, square root of 6. So we get square root of 6 squared is 6. In the variable form, it's a square root of a squared is equal to a. But you see here, if you have negative 6, this does not work. So you have to say it's positive, non-negative. This formula only works for number greater than or equal to 0. Square root of a squared is equal to a. And the other one, if you have a square root of 6 and then you square it, you take square root first and square second, is always equal to 6. So square root of a and then you square it is always equal to a. Unfortunately, here we also require a is positive, because square root of a, you don't take square root for negative numbers, right? So square root, square, they are inverse operations for each other. So the example will be, for example, square root of 64. You recall that 64 is 8 squared, so it's equal to 8. And you have square root of 1 over 16. You must recall that 1 over 16 is 1 over 4 squared, so it's 1 over 4. And square root of 1.4, and then you square it. The square root square cancelled is 1.4. So to find the square root, you really need some memory. And here, there is an interesting connection between square root and absolute value. Square root of a squared is always absolute value of a. How do we get this? Check here. It's negative 6. Negative 6 squared, 36. Square root of 36 is 6. And we also know that 6 is absolute value of negative 6. Right? So they are both equal to 6, so they equal to each other. So remember, this is very important. And this works for all x, for all a, whatever a, positive, negative, 0, whatever. So square root of a squared is always equal to a. Absolute value of a, absolute value of a. Square root of a squared is always equal to absolute value of a. And next part, they have some so-called scientific notations. Scientific notation is about the usage of a 10 to certain power. Possibly this is the only place you see this scientific notation in this textbook, so you read it. I will skip it. I will not discuss it. It's just a notation, writing. Basically, it's this way. If you have a 20, you will write it like 2 times 10. If you have a 2000, you will write like 2 times 10 cubed. 10 cubed is 1000, something like this. Or if you have a 0.02, you write like 2 times 10 to negative 2. Because 10 to negative 2 is 0.01. So times 2 is 0.02. Whatever. So you read this part. It's not long. And when you have positive power, you just move the decimal point to the right. When you have negative power, you move the decimal point to the left. For example, you have a 2 here. Its decimal point is this place. Negative 2 means you move it 1 place and 2 place. So decimal point is here. You have to add to 0. So that's why they'll have 0.002. You have 2, 3. You have 2. And decimal point here you have 1, 2, and 3. So you get 0, 0, and 0. So you got 2000. Well, that's it. Okay, so we finished the section R.2. R.2 is just about the operations, about the ops values, real number lines. And you have variables, you have to evaluate the variables, you have the power functions, exponents, and how to handle the exponents, and you have this important relation between the square root with ops value. Square root of a squared is equal to ops value of a. Very, very, very important. Keep in mind. Okay? Okay, so let's see what's next. Yeah, let's start it. This video will stop. I will have another 30 minutes video, and we will start section 1.1. Okay, so let me stop it now, and we will start next.